It's
Uh,
okay.
okay. Thank you to the host for the kindly introduction, and to the organizer for the invitation. I am so great to have this opportunity to share and exchange idea in Tilapia webinar with experts from both academia and industry. So good day, good evening, everyone. My name is Zhang Wenhuang. Come from Department of Aquaculture, National Taiwan Ocean University. So my research topic is focused on the genetics and the molecular breeding of economically important aquaculture species, major in tilapia and ornamental shrimp also. So I work with Professor Gong and Professor Xu in aquaculture genetics and breeding. And we also collaborate with a partner. Here I show you Dr. Lin, Zhongyan Lin, and Yang Wenqing, Dr. Yang Wenqing from Academia Sinica, and Wang Ronghua from our AI Research Center team. So today I will share our research work on tilapia, and the title is Integrating Genomic Breeding and Functional Nutrition in Tilapia Aquaculture. So today I will cover five parts. One is a white tilapia, and the second one is a genomic molecular breeding. Third one is a functional nutrition and industry application. And finally, I will give some future work. So okay, so we go through the why we chose the tilapia as a idle species, because we know the tilapia is very important in the aquaculture. It grows fast and adapt well, and is easy to farm. So it's a good species for innovation. In addition, tilapia is low cost and widely accepted by consumer. And it can use plant-based free and has a lower environmental impact. From the breeding view, so it has a high genetic diversity. So it's a also good model for modern breeding. So,
Hello.
however, aquaculture faces so many challenges, something like population growth or disease risk, climate change, or stress, and limit some resources. So, at the same time, consumer want to better quality and safety product. So, traditional methods are not enough. So now aquaculture is moving to an integrated system. We manage water, fish, feed, and health together. The goal is simple, stable production, better efficiency, and better product quality. So it's a gene to table concept. So we know traditional breeding is still important, but it give us a strong foundation. But now we need to improve many traits at the same time. So we need more precision tool. So the second part, I will go through our research work focus on the genomic molecular breeding. Before we select fish by appearance, but now we use DNA information. So we choose or select not only good fish, but also right fish. So in Taiwan, tilapia breeding have a long history. We improve growth and create important strain, something like red tilapia, common tilapia, or monosex tilapia. But a traditional method mainly really on visible trait. So it is hard to improve multiple traits together. So genomic tool can help us solving this problem. At our university, NTOU, we built a integrated genomic breeding platform. we combine genotype and phenotype data. We can track fish management, family, and select candidate. And we focus on the growth, disease resistance, quality, and stress tolerance. And we use a genomic tool such as genomic database and transcriptomic analysis and molecular marker. This tool help us find so many key functional genes and improve selection accuracy. And we also build the DNA barcode and the genomic database. So this help us management broodstock and keep genetic diversity. And we can quickly find useful gene for the breeding and the selection. And for the genomic database section, we also collaborate with Dr. Lin from Institute of Information Science, Academia Sinica. Our team has already set up the database that include the genomics and the transcriptomics. So this make us easy for to selection or search for important functional gene and genetic marker from the database. And we study important trait, something like salinity tolerance or cold tolerance. And here I show you the salinity tolerance example. We already identify key functional gene and validation by qPCR. And we also made a quantitative trait loci to link gene with the trait. So this result we can directly apply or use to marker assistance selection in breeding program. And we have published this finding in international journal, including our recent paper in aquaculture. And we also collaborate with Dr. Huang, Wang's team to use AI technology and help in the collection of phenotype data with different traits of Taiwan tilapia. So AI can help us correct phenotype data automatically. Okay, so I show you. And up to now, we already developed both microsatellite, sometimes we call SSR, and SNP marker. So this marker already proved have a strong link to the salinity tolerance. So we can select a fish at the early stage. So this improved already improved the efficiency and accuracy. And here I show you the SNP marker for the salinity tolerance. So using SNP genotype, we can clearly separate different genotypes such as CC, CT, and TT. And we find that those genotypes are strongly associated with salinity tolerance. For example, tolerance population show have a high frequency of the favorable genotype. And this allows us to classify individual more precisely based on their genetic profile. So SNP markers are very useful for genomic breeding, especially for early selection and broodstock management. So one of our key results is a high fillet production strain. Sometimes we call Mighty MIT1 is a Mighty Tilapia #1. It was developed by our team, led by Professor Gong. This strain show very good fillet performance, which is important for the market value. So if you are interested, you can contact our team, Professor Gong. You will welcome to contact. Okay, so we use all the genomic tool already developed several strains, something like salinity tolerance, cold tolerance, and disease resistant and high fillet yield. So this strain perform better in the real farming condition. Okay, so the third part, I will talk about the functional nutrition because I know that three experts will show more detail insight later. So here I just briefly introduce the basic idea and some of our early results. So some of our data are not yet published, so I will keep this part simple. So thank you for your understanding. We use a plant-based additive as a neutral feed, so they can improve the immunity, gut health, and metabolism. So we also combine the nutrition with genetics in the future. So this is a precision breeding. So we test the biting bilosa as a feed additive. So here I just show you the design, and the fish have show the result have a better survival under the salinity tolerance. So we also have a better growth and gene regulation. And we also study gut microbiota because the functional feed improve the probiotic, something like beneficial bacteria and reduce harmful one. So this support better health and adaptation. So here I show you is the integrated data from the metabolized microbiome and genetics. So this help us understanding how diet affect the performance in tilapia. So the fourth part now just for the application. So we focus on from the result to value creation of the commercialized product. Recently, we have published the paper and the book and the journal conference. So this show our research work is recognized internationally. So here I show you our the book chapter. Professor Gong and me, we write the two chapter focus on the transcriptomic and gene editing. And we also active join international conference and academic exchange. So our team collaborate with researcher and from a different country, including cross-strait cooperation. And we also work very closely with both industry and academia. So we collaborate with the fish farmer and the company and the research institute. And we also focus on the technology transfer. We transfer our research result to the tilapia sea industry in Taiwan. And this include the breeding technology and the precision selection tool. And we work closely with a younger farmer. We provide a high quality tilapia fry and growth them together in the real farming condition. From the breeding, stocking, and harvest and processing, we build a complete the production model. And we use our patent biotechnology together with industry experience. So this help improve the production and the farm management. So our students and our breeding team also received a national award recent year. Okay, so because my time will limit, so finally I will talk about our future plan. We will continue to develop better tilapia strain using advantage breeding and genomic tool. At the same time, we aim to strengthen industry collaboration and explain real world application. So in the future, we already and will better combine genotype data with phenotype data, and also integrate transcriptomic and metabolomic information. So this help us link gene to the real trait more accurate, and we can select a better tilapia strain that are more suitable for farming. And how to do? We first build a reference or establish a reference population to study important traits, something like growth, disease resistance, or stress tolerance. Then we combine the phenotype and the genotype data and use a GWAS analysis to develop a breeding value prediction model. So this model can help us estimate which fish have a better genetic potential. And we also use AI as a tool to improve accuracy and validation. So finally, this model can be applied to select high quality fish in commercial population. So this slide is a finally slide. We will show our precision breeding approach. We work with a seedling farm to produce high quality Taiwan tilapia. Compared to the traditional breeding, we use genomic marker to select better fish more efficiently. So this meaning faster selection and more stable performance. So in conclusion, tilapia is very important in the global aquaculture. So we have built a strong breeding system and use genomic data and the AI tool to improve key traits. But looking forward, the future of the tilapia farming is not only about a better feed, it's also about better genes or genetics. Thank you. So here I will thank all the partner list on this slide, and all my member also. Thanks for your attention.
And thanks for all the clear and practical sharing. And it has given us new idea on tilapia breeding from genetic level.
Yes.
Thank you very much.
Thank you.
And now it's time for Q&A session. If you have any question about tilapia breeding, genomic selection, or diseases resistance of fry, please feel free to ask. And you can also type your question in the chat box. Professor, you can see in the chatting box there is a question.
Yeah, so so many. I'm sorry because the time is limit, just only 20 minutes. So I need to briefly very quickly. So sorry, maybe some information not more clear. So maybe you can write some or ask some questions. I can respond. Have one question. Which genomic marker are associated with better response to functional diet in tilapia? Yes, it's very good questions. Because up to now, we just perform this project. Because we want to select which genotype are most sensitive linked to the feed component. So because now I cannot show the data and maybe after, and we need to obtain more data and to combine our genomic breeding model. So this time I cannot show you the result. Okay. But I think so many research team in the world, they just focus on this topic because the genetics and the nutrition, how to combine is more important. Is an important issue. Yes. Today I just show all the trade. Just focus on the salinity, tolerance, cold tolerance, and disease tolerance. Resistant. But we know growth is growth trait is more important in the industry. So our stream already crossbreeding with the high growth rate stream. So we combine all the correct and send send our fish fry to the industry, so have a good performance. So up to now, we already created the new company for this business model and collaboration with our industry and other foreign country, something like Brunei or Thailand or Indonesia also. Yes. And have one question just show, because SNP marker so many marker you need to test. But up to now, we know the microarray or SNP array can screen all the individual or all the fish by using maybe 100 or 200 SNP marker, but it's more expensive. We know not useful. So now we select the SNP major effect. I think is very important, and the more cheaper, more can apply to the industry. I think is more important. But in our academia research work, we need to identify which functional gene can regulate the growth or economic trait, and to identify or clarify the mechanism. Yes. Okay, so I think the question, because so many questions.
So many
Maybe
questions.
after I can solve it.
Thanks for the questions, and later we will collect all the questions and organize the answer with
No problem.
in word, and we'll answer everyone's question.
Okay.
Okay, thanks,
Okay.
Professor.
Okay, thank you.
Thanks for your wonderful answer.
Thank you.